So we're gonna talk about units today, but units of degrees versus radians. So you guys are pretty good with understanding that like centimeters is a way to measure things, and so is inches, and then there's some magic value that you know that 1 inch is equal to this many centimeters. You could convert back and forth between them. And some people might give you a length in centimeters, and some people might give it to you in inches. So the same thing is true about the positions on our unit circle. We've labeled them all with degrees in reference to the circle, but there are two ways to measure those positions. One is in degrees, but the other is in radians. That's why your calculator had those two mode options, degrees or radians, kind of like centimeters versus inches. So when you're doing degrees, you're basing it on the fact that all the way around the circle is 360, and then you're just breaking that up into smaller chunks around the circle. That's how we're knowing where all those marks are. To convert it to radians, you'd have to know one magic value, right? Like how many radians are there in a degree, or how many degrees are in a certain radian. So what I want you guys to understand is that a radian is more like taking a ruler, or a tape measure would be a better idea, and measuring units around the circle. But instead of it being like centimeters or inch units, it's radius units. Like how many radiuses of the circle does it take to go around the entire circle? Okay, so around the edge of the circle, what measurement is that called when you like took your geometry class, or we've used it earlier in this course? If you're measuring around the edge of a circle, that is called circumference. Okay, so since we're thinking about the edge of circumference or around the circle, I want you to think about circumference for a minute. So circumference is equal to, do you guys remember the formula? No? It's equal to 2 pi r. Okay, now our unit circle has a radius of 1. So the circumference of our circle is 2 pi times 1, or specifically 2 pi, okay? So the circumference of our circle, if you want to go all the way around the circle in degrees, you say, I went 360 degrees, but you think about that like the clock of a hand going around a certain amount. When you say I want to go all the way around the edge of a circle, you think about a tape measure. The measurement comes out to be 2 pi, but that tape measure wouldn't have ticks for every inch or for every centimeter. It would have it measures for every radius. Like here's 1 radius, 2 radius, 3 radius, 4 radius, etc. And you'd be measuring around the circle, and it would take 2 pi radii, that's what radius is, you know, whatever you want to say, okay, to get around the circle. Is that all right with everybody? Okay, that means when we look back at our circle, so flip your circle over for a second, and we look at these marks, 0 is still in the same spot. And the other name for 360 would be 2 pi, because in radii, it takes 2 pi of them to get around. And if you're like, what is 2 pi of them? Remember, pi is like about 3.14. So 2 times 3.14 is 6.28. So about 6.28 radii. So if I literally cut a piece of string the same size as the radius, it would take me 6.28 of them to go around the entire circle approximately. Okay, that's what this is measuring. I know it's a weird way to measure, but somebody made up inches and centimeters, and somebody else made up, I'm going to measure it in terms of how big the radii is. Okay, whatever. All right, so 0 and 2 pi. What does that mean would be at 180? What would 180 degrees be in radians? If 1 time around the circle is 2 pi, what would it take to go halfway around the circle? 1 pi, right? So 180 degrees in radians is pi. So our radians are not going to be as friendly, okay, for 2 reasons. Number 1, you're not used to using radians. Number 2, if this is 1 whole, that means all of these marks here are something smaller than a whole pi, which means they're going to be written as some sort of fractional form of pi, which generally you guys have told me you don't enjoy fractions. So that's going to bother you a little bit. So I'm just putting that out there up front, okay? Now we're going to do a conversion. I'm going to show it to you the conversion way, and then I'm going to show you how we could do it another way, because I don't want you to convert every time. That's going to make your life pretty miserable. It's going to make it take a long time to do things. But just so that you understand a little conversion review. So if we were going to convert degrees to radians, think about our 30-degree mark on the circle, okay? This is currently measured in degrees. That's what the little bubble means, right? I'm going to write out the word so we can think about it with our conversion. 30 degrees. I want to change 30 degrees into radians. So in the end, I want my answer to say some amount of radians. So we talked about this with your golf course, okay? We've talked about it at least one other place in our class where we do unit conversion, and we can do it a lot like rational functions, like canceling things out. This means I'd like to multiply by some fractional thing where the degree measurement is canceled out, but I'm left with what I want, which is radian measurement. Is that okay with everybody? Like, that's my goal. Now, in order to achieve this goal, I do need to know one key piece of information. I have to know some amount of radians that is equal to some amount of degrees to build this fraction right here that's really worth 1. Like, this is the same thing as this, just measured in different ways. So the thing that we use is the simplest of the unit circles. So we basically figured out 0 is 0, but that would be not useful to use here because 0 over 0 is some crazy undefined mathematical thing. The other thing we knew is that 360 degrees we just marked on our circle is 2 pi radians. So we could use that, but we can reduce that a little bit. And the more reduced version of that is what we marked at your 180 mark. We know that 180 degrees is equal to pi radians. Is that okay with everybody? So because we know it takes 2 pi to go around the whole circle, we know half the circle, or 180 degrees, takes 1 pi. That's the simplest comparison for us to use, okay? And so then we would want to reduce the 30 and the 180. The 30 is in the numerator and the 180 is in the denominator. 30 actually goes into 180 6 times. And so 1 times pi makes pi, and 1 times 6 makes 6. So 30 degrees is the same thing as pi over 6 radians, or a sixth of pi. Usually people say pi over 6, but in our heads it makes more sense like it's a sixth of pi. Okay, so let's go back to our unit circle and mark the pi over 6. So 30 degrees is the same thing as having pi over 6 in radians. Now, if you're like, unit conversion did not make sense to me, let me try to help it make sense for you in a different way, okay? You guys know that halfway around the circle is 1 pi, right? If you make a cut at 30 degrees, how many 30s are in 180? If I cut every 30 degrees, how many pieces am I getting to get to 180? 6 pieces. I can call 180 pi, and if you cut it by 30, you just cut it into 6 pieces. 1 pi cut into 6 pieces is sixths of pi. Is that okay with everybody? So it makes sense that our 30s are in sixths. Any idea what 60 would be? How is 60 related to 30? 2 times 30, right? Twice 30. Okay, so 60 would just be 2 pi over 6s. We could literally count around the circle just like we counted by 30s. Do you guys remember how we counted by 30s? If I leave out the 45s, I can count around the circle by 30s, but instead I can call them sixths. Remember when we were doing our golf project and you guys hated measuring with inches, and we said if all else fails, since we know every little mark is 1/16th, just count like 1/16th, 2/16th, 3/16th, 4/16th. We can literally use that same idea here. You can use that anytime you know something is split up into equal fractional amounts. Every 30-degree chunk, I can count one more pi over 6. So I could count 1 pi over 6. Then this 60 would be 2 pi over 6, but 2 and 6 reduce, right? So what does that end up looking like? Pi over 3. Okay. So that was 1 pi over 6, 2 pi over 6. If I go another chunk of 30, that will be 3 pi over 6, but 3 over 6 reduces to pi over 2. All right, so I'm losing track. 1 pi over 6, 2 pi over 6, 3 pi over 6. The next 30 chunk would leave me at 4 pi over 6, but 4 over 6 reduces to 2 over 3. All right, so that was 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, then 5 pi over 6. Okay, that doesn't reduce. Then one more would be 6 pi over 6, and 6 over 6 is 1. Danielle?
2 over 6 is next.
Oh, yeah, 2 over 3. Thank you. I said 2 over 3, but I wrote 2 over 6. Make sure you correct it if you wrote down what I wrote down. If you wrote down what I said, you probably were okay. If you wrote down what I wrote, you probably were not. So this at 120, it should say 2 pi over 3. Does this make sense to everybody? Okay. And notice you kind of see a pattern, right? At these endpoints, we see whole values of pi. And halfway between them, we see a half value of pi. And even though we could count the 30s and the 60s by sixths, notice the ones we highlighted in yellow before, the ones that were actually 30 degrees away from the axis, didn't reduce and they stayed with a sixth version of something. However, the ones we called 60s, the ones we highlighted in green, even though we could count them with the 30s and the sixths, they reduced to something with 3 in the denominator, like thirds. Okay, and we could keep going that way, right? I'm going to let you guys try to figure out some more in a minute, so I'm going to let you guys do the bottom half of the circle. 30s and 60s, remember, are super related. We keep seeing them kind of overlap. They have the same numbers here, but just different order. We could count 30s and 60s at the same time. That's all because they were in the same right triangle. 45, 45, 90 was an entirely separate triangle. So you really want, there's really 2 circles here we're paying attention to, right? One is about like 30, 60 patterns. Another is about 45, but we don't want to make 2 separate ones, so we put them on the same one, okay? So now we could go through and do 45. So we can go convert it again if you wanted, or you can use kind of what you know. 45 is halfway to 90, okay? But now let's think about that in radian world instead of degree world, okay? 90 in radian world is pi over 2, a half of pi. We want half of that for 45. What is half of a half? A quarter, right? Think dollar. Think if you had 4 quarters out there. Half a dollar is 2 quarters. Half of the half would be 1 quarter, right? So 45 degrees is a quarter pi, or pi over 4. Once you know that 145 degree is pi over 4, you can do what we just did, and you could count around the whole circle by 45s rather than by 30s and 60s, but when you count by 45s, make sure you're counting the right marks, right? It's only every 45 degrees, so it's here to the blue, to the 90, to the blue, to the 180, to the blue. Okay, so I'm going to count around the top by fourths, and then I'm going to let you guys try to figure out the bottom half of the circle in radians. So this would be 0. This would be 1/4 pi. 90 would then be 2/4 pi, but again, that reduces to be 1/2. That means 135 would be 3/4 pi, so 3 pi over 4. And then 180 would be 4/4 pi, but 4 over 4 reduces to 1. Is this okay with everybody? So you can always convert them back and forth. I'm trying to give you multiple perceptions so you can kind of figure out what's going to work for you. Part of the way, since I'm giving you the unit circle, so like as a person that had to learn the unit circle, I have memorized, like, so I'll tell you guys how it works for me. I know 30 is pi over 6 because I memorized it, okay? That 45 is pi over 4 and that 60 is pi over 3. But you guys are going to be given this. So I've basically taken that memorization away for you, because if I'm giving you this, you can literally just look and see every 30 degrees is pi over 6, every 45 is pi over 4, and every 60 is pi over 3. That's right in front of you. You're not going to have to convert it or to memorize it. Now, when I give you some crazy numbers, though, you're going to have to know, oh, it's over 3. Let me go back and use this wisely. If it's over 3, it's referring to some sort of 60-degree increment, and then you're going to have to try and figure it out. That's why I want you guys to learn the patterns. Just like yesterday, we did things that were bigger than 360 and negative. You're going to see those same things show up today, and with radians, they're a little more difficult because we're just not as familiar with them. So I want you to know the patterns well, okay? So take a couple minutes. You can do it by yourself. You can do it with the person next to you. Fill in what you think the radian measurements would be for the lower half of the unit circle. Okay, so I'm gonna fill mine in, and I'm gonna fill mine in not by counting around. I think counting is a perfectly good method, or I wouldn't have shown you, but I'm trying to give you guys multiple ways to look at it so you can kind of figure what pattern works best for you. So counting is totally fine, but can you imagine if it's like 5 times around the circle and then more, like you might be counting a lot? So what I wanted to try and do is give you also a little bit of perspective, okay? So notice that I could keep counting. There's nothing wrong with that, okay? But I also wanted to give you, like, there are some key things that can be really, really helpful in quickly figuring it out without counting. For example, since 180 is pi, but sometimes I'm seeing sixths, and sometimes I'm seeing fourths, and sometimes I'm seeing thirds, sometimes it's helpful to think about 1 as 6 over 6, or as 4 over 4, or as 3 over 3. So for example, if I think about 180 as 6 over 6, and I know that the sixths go with the 30-degree angle, I know the 30 degrees past 180 is 1/6 past 180, okay? If 180 is 6/6, then going 1/6 past that would be 7/6. So what you should have marked at 210 in radians is 7/6. 7 pi over 6. Using that same logic, if I'm going 145-degree angle past 180, and I know that 45s are like pi over 4s, then I would think of 180 as 4 pi over 4. Going 1 past that means the 45 that's past 180, that 225, should be 5 pi over 4. Okay. Going 160-degree angle past 180, 660s are counted by thirds, is like going 1 extra pi over 3 past 180. If I think about it in terms of thirds, 1 pi is 3 pi over 3. Going 1 more would be 4 pi over 3. Okay? I'm not counting. I'm just trying to skip all the other counting and get there. Okay? So you can also think about it as almost reaching a place. For example, if the end of the unit circle, or one lap around it, is 2 pi, okay, think about 2 pi in these other measurements. If you want to think about it in terms of sixths, because you're dealing with a 30, 2 pi would be the same thing as 12 pi over 6. So if I know I'm at the 30 right before I complete the whole circle, I'm at the sixth that's right before I get to 12/6. What's the sixth that's right before 12/6? That would be 11/6. Okay, so I could count all the way around, or I can use that logic to help me do it without counting every spot along the way. Okay, same with fourths. Okay, 45s are measured in fourths. If I know I'm thinking about the whole circle being 2 pi, which is like 8/4, the fourth that comes right before I reach 8/4 would be 7/4, so 7 pi over 4. If I know I'm at a 60, and 60s are measured in thirds, okay, if I think about a whole rotation of the circle, 2 pi, but in terms of thirds, that would be like thinking about 6/3. The thirds that's going to show up right before 6/3 would be 5/3. Okay. You could do the same thing with halves, the half that shows up right before you get to the end. So if we thought about it in halves, 2 pi would be like 4 pi over 2. So this one's like 3 pi over 2. It's like 1.5. Okay. Are we all okay with how those are labeled in radians? Right, so I'm basically going to give you 6 questions like I gave you yesterday. 3 that you can see on the circle, 3 that are more than 100 or more than 1 lap around the circle, and 3 that have some negative values and might be more than 1 lap around the circle. And we're going to do the same calculations we did yesterday. We just have to speak a different unit, right? Instead of speaking degree and being given the problem that way, you have to be able to translate it when you're given it in radians. All right? Okay, so the problems that we're going to do, we'll do it group by group. So first group, I'm going to zoom out of my circle. I know you can't see everything, but my hope is now you have everything written down on the circle. Okay, so we're going to do sine of 3 pi over 2. We're going to do cosine of 5 pi over 6. And tangent of 5 pi over 3. We're going to start with these 3. All right, so what's the knowledge you have to have? If I'm going to hand you the unit circle, you have to understand the patterns on it, right? And what's the thing you have to have association with in your mind in order to do these calculations? What do you have to know about sine? It's like the y coordinate at these positions, whereas cosine, the x, and tangent, y divided by x. That's the stuff you've got to know. Okay, you've got to know the patterns in case you have to get somewhere that's not marked on there, and you have to know how to do sine, cosine, and tangent. So sine of 3 pi over 2, when I read that, I say sine is the y coordinate, and then I go to 3 pi over 2. You should recognize that as a radian. This radian is marked on your circle. Okay, 3 pi over 2, that's the same as 270. The sine at that position is -1. Okay, because the y coordinate is -1. Right, cosine of 5 pi over 6. And if you're having a hard time with knowing where to look, I would again say go back to your first quadrant. When you see a problem that has 6 in the denominator and you're not sure where to look, if you just look at the first quadrant where it has like each measurement, the ones that reduced and still were in terms of 6 were 30s. That means you should be looking 30 above and 30 below the x-axis, and you should see if you can see 5 pi over 6. Okay? So 5 pi over 6 ends up being here. Cosine is the x-coordinate, and the x-coordinate at that position is negative rad 3 over 2. So the cosine of 5 pi over 6 is negative rad 3 over 2. All right, and then tangent of 5 pi over 3. Again, if you're like searching and you feel like you're not seeing it, what are pi over 3s? Which one's reduced to thirds? 60s. So I should be looking further away from the x-axis. Up here, down here, or down here. The ones I have highlighted in green. Okay, and as I look at those, when I look at 5 pi over 3, 5 pi over 3 is here. Okay, and then define the tangent, I need to do the y divided by the x. So in this case, I need to do negative rad 3 over 2 divided by 1/2. So we have negative rad 3 over 2 will be multiplied by the reciprocal of 1/2. And I get negative rad 3. Okay. This one's nice because the radical is not in the denominator, so you don't have to go do those extra steps. So this is just negative rad 3. So any questions on sine, cosine, or tangent here? So this is kind of a review of what sine, cosine, and tangent are, because these angles were on the circle and labeled, so they aren't as difficult to find as some of the other ones that we'll see. Okay. No questions about this? All right, next 3. I'm going to erase on mine so I can keep my unit circle still in view and not have to like keep moving back and forth, but you guys can, obviously you'll want to keep your examples. All right, next sine, cosine, and tangent that we're going to do, we're going to calculate the sine of 17 pi over 6. The cosine of 18 pi. And the tangent of 9 pi over 4. So all of these are bigger than 1 lap around the circle. How would I know that just looking at the values? What am I comparing them to? I'm comparing them to 2 pi. Good. Okay, 18 pi is clearly bigger than 2 pi. How do I know 17 over 6 is more than 2? Because 6 goes into 17 more than 2 times, etc. Okay? So you guys have a couple of ways you can do this. Way number 1, you could literally count. Okay? Here, if you're counting by 6, you're counting every 30 degrees. Okay? So you could count 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. And you could just keep going till you got to 17. Okay? Option 2, at least take out the part that you know. Again, this is super handy. If I think of 2 pi and I understand what that is in sixths, 2 pi is the same as 12 pi over 6. Okay? When I'm looking at 17 pi over 6, how many 12 pi over 6 can fit in that? 1, right? That means it's 1 whole lap and some extra. How much extra specifically? 5 pi over 6. That's actually one that's going to be labeled on here. So you know it's a whole lap and then another 5 pi over 6. So just like with the degrees, how we like subtracted 360 when the number was too large and saw what was left over, you can do the exact same thing here. It's just that instead of subtracting 360, you're really subtracting 2 pi. You just want to subtract it with a common denominator to what you have. So if I do 17 pi over 6 minus 12 pi over 6, I'm left with 5 pi over 6. That tells me this is 1 whole lap and then an extra 5 pi over 6. Okay, so this is the same position at 5 pi over 6 as 17 pi over 6. And so the sign at that location is the y coordinate, which is 1/2. Okay. All right, 18 pi is a whole number. Where do you see your whole number pi's on the unit circle? On the x-axis, right? They're either at 0 or like 180, okay? Notice how this works. Every 1 pi, so like I could count 1, 2, 3, 4, all the way until I get to 18, okay? Any guesses where 18 is going to end up? Is it going to end up at the same location as 0 or as 180? 0, because 18 is even. Okay, so every time you go 2, you end up here. If you go 2 and then just 1 extra, you're going to end up over here. So you could count it, okay? Or you can understand that an even whole number is going to end up the same place as 2 because you're just going to do 2 9 times and land at that spot. So 18 pi is the same as landing at 0 or 2 pi. And the cosine there is the x coordinate, which in this case is 1. And then our tangent of 9 pi over 4. So when you see that it's reduced in terms of fourths, like it can't reduce anymore, and so the most reduced version is a fourth, what kind of angle is it going to be? Is it going to be a 30, a 60, a 45, a 90? What? A 45, because those ones reduce in fourths. So you have a couple of options. You could count by 45s, and you could specifically count 9 of them. 9 of these 1/4 sections. So I could go like 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, etc. Or I could count, but I could take out the whole circles that I know exist. 1 whole lap around the circle in terms of fourths is the same as 8 pi over 4, okay? So if I took out a whole lap around the circle, 8 pi over 4, out of the 9 pi over 4, I would only have left 1 pi over 4. So whether I count or do it that way, I should land at pi over 4 as the same position as 9 pi over 4 and calculate the tangent. Remember, the tangent is the y divided by the x, and remember what we talked about yesterday? In 45s, even though they're complicated numbers, since y and x are the same number, what value are we going to get every time we calculate the tangent at a 45? 1. Okay, it might be positive, it might be negative. In this case, it's positive because it would be a positive divided by a positive. Okay. Any questions about getting more than 1 lap around the circle? You can rely on counting. You can rely on understanding 2 pi in different ratios, so that will help make your counting a little bit simpler. Okay. All right, the last thing we're going to do is look at negative values. So we're going to do the sine of negative 7 pi over 4. We're going to do the cosine of negative 11 pi over 3. And we're going to do the tangent of negative 7 pi over 6. Okay. All right, so negative again means what? We got to go backwards around the circle. So none of these are marked for you, okay, because you're going the other way. So you're not going to land at the same positive location as the negative unless it's a whole time around the circle or half a time around the circle. Those are the only ones that land in the same spot. So negative 7 pi over 4. You have a couple of options of how to do this. I'm going to talk about the same options as yesterday. So option 1 is understand what positive 7 pi over 4 is and try to do that in the negative direction. So positive 7 pi over 4 is from 0 through 1 quadrant, 2 quadrants, 3 quadrants, and halfway through the 3rd quadrant. It's almost all the way around the circle. It's 145 degree away from completing the circle. So if we do that in the negative direction, okay, then I would go 1 quadrant, 2 quadrants, 3 quadrants, halfway through the 3rd quadrant. There puts me at the positive 45 degrees, okay? So that positive 45 degree location is the same thing as negative 7 pi over 4. The other option is to count the other way. You would have to recognize that pi over 4s, if you're going to count in terms of fourths, you're counting 45 degree chunks, and then you would go backwards, like 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7 pi over 4. Okay? So either way we land there, the cosine, or sorry, the sine there is rad 2 over 2. So again, same ideas as yesterday. Either understand what it is in the positive idea first and try to do that negative, or just count in the opposite direction. Okay? So negative 11 pi over 3, okay, is a third. Is 11 pi over 3 marked on your circle as a positive value? No. That's because 11 pi over 3 is more than 6 pi over 3, so that's more than one lap around the circle. Okay, you can still try it as a positive and then try to understand what that would be as a negative. As a positive, if I was dealing with the number 11 pi over 3, that would mean a whole lap around the circle, right? That's 6 pi over 3. 11 minus 6 leaves me with 5. So I have 5 more pi over 3. So it's a whole lap around the circle and 5 pi over 3 more, which is to here. So it's a whole lap around the circle, and then it's 1, 2, 3 quadrants, and then that 60-degree angle marked down here. You could then try that the negative way. A whole lap around the circle, and then 1, 2, 3 quadrants. It's going to be this 60 marked right here. Okay? Option 2 is you could count by thirds. If you count by thirds, be careful. What are you counting by if you count by thirds? If I count by pi thirds, 60s. Make sure you're actually making 60-degree jumps as you count. So if I go 1 pi over 3, and then I go 60 plus 60, do I land at 90? No, okay? 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7, 8, 9 pi over 3, 10, 11 pi over 3. Okay, so I can count, or I could think about it what it was as a positive and then try to understand that as a negative. Okay, either way, that negative 11 pi over 3 should land me at this same spot as positive pi over 3. And cosine is the x-coordinate, so in this case, that would be 1/2. All right, then tangent of negative 7 pi over 6, so you can count by sixths. Sixths are counting in how many degree chunks? Look at the unit circle. 1/6 of pi is equal to how many degrees? 30. So I could count in sixths, and I could go 1, 2, 3, 4, 5, 6, 7. I could have good understanding that 1 pi is equal to 6 over 6, which is so close to 7 over 6. So it's just like the 30 past half of a circle, but in the negative direction. Or I could look at 7 pi over 6, because it is labeled on my circle, in the positive direction and understand it's half a circle and then 30 more. And then I could do that in the negative direction, half a circle and then 30 more. Okay. Either way that we do that, negative 7 pi over 6 should put us at this same position as 5 pi over 6. Okay. And then our tangent is the y-coordinate, which is 1/2, divided by the x-coordinate, which is negative rad 3 over 2. So that's 1/2 times the reciprocal of rad 3 over 2, which is negative 1 over rad 3. And then we've talked about not leaving that radical in the denominator. So instead of writing it like this, we'd multiply top and bottom by rad 3. And that creates a whole 3 in the denominator, but a radical in the numerator. Okay. It's all right with everybody? Okay, so new type of measurement, but lots of patterns and ways that you could catch on to them. So that's going to kind of be your goal, is to latch onto the patterns that help you explain it best. Remember the info that you're getting and be resourceful. If you're getting this information and you're like, I can't remember which one's a third and a sixth, you're not being asked to. You're being given this, and it says right next to 30 that that is the same thing as 1/6. So if I'm counting in terms of sixths, I'm counting in terms of 30s. If I'm counting in terms of fourths, I'm counting in terms of 45s. If I'm counting in terms of thirds, I'm counting in terms of 60. Okay? So that's what you guys should pay attention to.